Today we will solve direct map cache problems. Here is the given information about the problem. The first step is to convert the sizes of memory and cache into base 2. Let's first figure out the bits of the virtual address. To determine the number of bits in the tag address, we must first find the number of tags in memory. You can do this by dividing the total memory size by total cache size. This will give you 2 to the power 14 tags. Take the log base 2 of 2 to the power 14. The result is a 14-bit tag address.
To determine the number of bits in the line address, we must first find the number of lines per cache in memory. You can do this by dividing the total cache size by the bytes per line. This will give you 2 to the power of 13 lines. Take the log base 2 of 2 to the power of 13. The result is a 13-bit word address. To get the word address, you subtract the tag and line address from the physical address. This result is a 5-bit word address.
Now we have all the pieces to the puzzle. Now we can solve our question. We have a main memory cell with a hexadecimal address of 000E602. Now we can convert this number to base 10. You should get 58882. Let's determine what line in cache this is all in. To do this, we must convert the hexadecimal address to binary. Using the tag line word, we can break up the binary address into its respective parts. We converted the 13 line address bits into base 10, which will give us the line address 1840. Remember that the line address starts at 2 to the power of 0, not 2 to the power of 5.
We repeat the same steps to figure out the word. We repeat the same step to figure out the tag.
To determine which block is in the cache, we must first get the number of blocks per tag. In this scenario, it is equal to the number of lines per cache because there's one word per cell in memory. So this is equal to 2 to the 13 blocks per tag. Now we multiply this by the tag of the given cell and add in the line address. In our case, the tag is 0, so we just add the line address. The result should be 1840. In order to determine what other cells are in this block of memory, we must first determine how many cells there are in a block of memory. So we have a 5-bit word address, and that gives us 32 words per line. And since one line in cache is equal to one block in memory, this must mean there are 32 cells per block of memory. We know from our earlier work that this cell is word number 2. So the first cell in this block must be 58,882, which is the cell, minus 2, which is 58,880. The last cell in this block is 58,880 plus 31 other cells, which gives you 58,911. So the cells in this block are the cells from cells 58,880 to 58,911.